We can start now. So my idea for hands-on session is as follows. It's a practice session, practice of what we have discussed in last two lectures. And of course, I have also discussed the, our codes, how to do the analysis. So I have talked about one data here, and this data is in the package FDP2. So you can install this package as well as you can install the other two packages like T-series and forecast, and then you just call these two packages into your R session, and then we talk about a data which is called US change data, and this data is having 1, 2, 3, 4, 5 time series data. So five time series are there. So that is essentially a multivariate time series. But as we have discussed only one-dimensional time series, the univariate time series. So idea is that to take one of them, and in this case you can take the consumption, and then try to analyze the consumption data. And note that in this case, again, we have data, but this is not a monthly data, but a quarterly data for each year. There are 4 data points, Q1, Q2, Q3, and Q4. So you can go for taking the consumption column from here, and that you can able to do using this chunk of code. Just unchanged is the US change is the data, and you need to take the consumption column. So that's why it is in the third bracket. It is comma, then consumption in the quote. And then if you do that, if you can see the head of the data, and head of the data look like this. It is basically you can see that okay, quarter for in year 1, year 70. There are Q1, Q2, Q3, Q4, and for each of them, this is the data, and so on. The whole data you can see. So then finally, our job is to fit a ARIMA model, check what check this PCA, ACF and PCF, and other diagnostic, other visual inspection along with statistical test to fit a AR model with that, and then go for residual analysis, and finally we need to access the accuracy of forecasting. Okay, so most of the codes I have already shared with you, I have already discussed and shared with you. So maybe we can start with that. You may try to do it on your own, and in case you have any difficulty, we can have discussion. Okay, so is it okay with everyone?
Yes, sir.
Yeah. So So I hope that you got this complete data by now. That so the data are starting from 70 Q1 and goes up to 2016 Q3. Okay, so how many data points are there? I can take this one. I can check this one. Basically, we have 187 data points. So it's not a very small data set.
Sir, how to make all these lines simultaneously put has before these lines?
Which line?
Like any three line, let any number of lines if you want to put the has simultaneously. How to do that?
No, I do not get your point. Any
So
number of
just
lines where you want to put.
let just say you selected the three lines and you have put the has before them. Commented those lines.
Oh, okay. How to do this one? Okay. The
Yeah.
commented this one. That is basically Shift Control C. That will if it is normal line, it will be commented. If it is commented line, it will be uncommented.
Okay. Shift Control C,
Shift
sir.
Control C. Yes.
Okay.
You
Thank you, sir.
can see it from here. This you go to code here, and then you see that this is given here.
Okay, sir. Okay. Thank you.
Okay, so just keep one thing in mind that you cannot take log in this particular data. The reason is that we have negative data point values in this case. Okay, this is the plot. So clearly that negative values are there. So taking log is not possible with this data.
Sir, when I'm plotting this function m by ts, So it is showing that figure margins too large.
Figure margins too large. Does it showing the same thing to me? No, it's not saying. So what you are doing, you are just writing plot MYTS, right? MyTS or whatever.
Yes, yes, yes.
That showing picture.
So in this case, just we have to write move the screens, right? This actually the file figure size is more.
Okay, okay.
So that we have to do that.
Yeah, thank you for.
I did that, but I don't know. It is not showing.
Okay. I think there is a way to detach it from here. Forgot that if we do zooming, what happens? Yeah, zoom. Just click on zoom, you see that whether that is still there or not.
Okay, let me try.
That this graph, are you getting or not?
No, I'm not getting the graph actually. It is just showing whenever I'm writing this command, it is showing error in plot figure margins too large.
You have increased this area.
Pardon, sir?
See, this area you can make smaller, make bigger.
Yeah, I did that, sir. But the graph is not even, while zooming it also, कुछ दिख ही नहीं रहा है उसमें.
Okay, so you are using Art Studio, right, or something else?
नहीं, Art Studio, sir.
You Art Studio only, okay.
हाँ. बाकी सारी चीजें आ गई हैं. ये नहीं हो रहा है.
Why it is?
Yesterday, so we were able to do like this only by increasing the area. We were able to get those.
Yeah, that's what you should be able to do. For me, any area is working. Why? This error has come now. This is gone. So you do one thing, make this area quite big, and then again issue that reissue this command. Is it working?
All right,
or not?
sir. Okay, I'm just doing it.
Yeah.
Yeah, now it is showing, sir. Thank you.
Yeah.
I did that. Yeah.
Sir, do we need to check the stationarity here? There is no, I think, no need because we will be directly applying ARIMA.
Now, do you think this data is stationary?
No, but we are applying the ARIMA, right? It will make the data automatically stationary, right?
Not always. It depends. If the only the differentiation make it stationary, then it's okay. Yeah, you do it. At least you try the ARIMA first and then check the error residuals. You check and see that whether the residual satisfies all the conditions or not. That is also fine.
Sir, here in this case, our auto ACFs are and PACF are going beyond the limits.
Sorry, what you are saying?
Here the PACF values are going beyond the limits.
Yes, two values are outside. 0, 1, 2. Two values are outside. Three values are outside. Initial three values, and then it is inside the range.
So what does it indicate, sir?
So both are going outside. That's what you are talking about, right?
Yes, sir, yes.
Yeah. So it is basically, I mean, ARIMA model. That means P and Q both should be non-negative, non-zero. Right. That's what we have pointed out during this table I have given to you.
That was regarding the either the zero decreases and cutoffs, but not going beyond the limits like.
No, see, what I am saying is basically, if you see this table says that one continuously decreases another cutoff, or another, I mean, ACF cutoff or PCF cutoff, another one is continuously decreasing or decaying. That is basically. And for ARIMA, both of them is decaying. So in this case, I can take that way. If this one is decaying towards zero, like in this range, it is very, very small. It is, I mean, continuously decaying kind of thing. And similarly, if you see the partial ACF, that is also the almost same kind of nature. That initially it is bigger than the cutoff, but after that it is inside the cutoff.
Yes, so that we can say for this, right, for that we will use the ARIMA model. But if there is a highly correlated, then will not it affect our answer? Because multicollinearity, right, will come into picture here. Because all the correlations are...
Multicollinearity is not coming here. But anyway, see here, basically two data I am talking about. See, one time series actually with lag, we are making it bivariate data. So our thing is that here we want the collinearity. That's what we want. Otherwise, how can we model it if the corresponding values are not correlated?
So then what these limits signify?
Which limit? This blue lines you are talking
blue
about?
Line, yeah, yes, sir.
So they are basically, see, if you want to test that whether the ACF or PCF is zero or not, then what you get? You basically get some cutoff that if the observed value is outside this range, we will take it as a non-zero value, and if it is inside that range, then we take it as a zero value, right? That is a standard way. You think about testing of mu equals to 0 in case of normal data. So what we have? We have two cutoff points. If the average is outside this interval, then we say that the mean is not 0. If it is inside that, we say that mean is 0. The same kind of thing is going on here. So these two blue lines are giving you cutoff. So if I statistically want to test, it basically says that these three PCF values are positive, rest of them are negative. Of course, here another positive is coming, but we can ignore it. It is a very large lag actually, that's why we can ignore it. Similarly, ACF also, we can see that initial 3, 0, 1, 2, 3, 4, initial 4. So these 4 values are positive. After that, everything is inside the range, inside the interval. So this ACF I can take as 0, whereas this ACF I can take as non-zero. That is basically this line actually talking about. Is it okay?
Yes, sir. Somewhat okay.
So why somewhat? Why not?
Because sir, then how sir these things will be taken into account into the model? Okay, that let for rest of the things the average is 0, but for this right, how then it is coming into the model, sir?
So coming into the model through this table, that's what I am telling you. That
yes,
see,
sir, that
in
is
this
decreasing.
case,
It is okay, but what is values are going outside the limit? Then how it is affecting the model means? If all the values let are inside the model, then what does it will signify? How it will affect the model?
if all the values are inside these two values, inside to this thing.
Yes, yes, sir.
So that basically means that there is no correlation. Actually, things are white noise. So and we cannot model this data. As simple as that. See, what is basically says, this value is basically 1 lakh correlation, right?
Yes, sir.
Okay. So if it is 1 lakh correlation, what is 1 lakh correlation? 1 lakh correlation, 1 lakh autocorrelation is basically correlation between xt and xt minus 1 or xt and xt plus 1, whatever you want.
Yes.
Okay. So that means that there is a correlation between two corresponding values in the time series.
Yes.
Okay. So that says that I have something I can model, something I can predict actually. If I know that today's value, I can predict tomorrow's value because there is a correlation between these two. Make sense?
Yes, yes.
So that's why this correlation is important for time series analysis. If there is no correlation between consecutive value, that means they are kind of a white noise. So that modeling does not make any sense. They are completely random. If there are some correlation between consecutive value, then I can, of course, I can tell, well, I can model it. I can tell something about future given present.
Okay.
Past.
Thank you. Thank you. So then in auto arima, right? How many legs of like P and how many Q and how much differencing and how much R will be used? And
See, if you use auto, it is taking automatically and it is giving this result, right? Basically, for ARIMA, the P is 1, it is not taking any differentiation, D is 0, and Q is 3. And this is corresponding to seasonal component.
So due to seasonal component means here, right? Because in ARIMA model we just only specify three values, but here we getting right these two
Yes,
consecutive sets.
that is you are basically getting because there is some amount of seasonality in this particular data. So when you use this auto ARIMA, it actually adjusts for that one also. That's what you are getting this. But if you just use ARIMA directly with these three values, 3003, of course, your fit will not be as good as this one, but will not be bad also. Okay. And another interesting thing here is that see this mean part. What is this mean part? Mean part actually basically tells us that I have a constant in the model. So basically when I discuss this ARIMA model, yes, when I discuss this ARIMA model, you see that I have not written any constant here, but there is a possibility that there may be some constant is added to that. Okay, and in this case, this mu, that mu estimate is coming out to be 0.0886. And that is also clear from this graph because you see this the fitted straight line actually somewhat little bit below than one. So and if you take the because other extreme points are there, so when you take the averaging, it turns out to be quite close to 0. If only one or two participants are talking to me, what about others? Are you getting or not? Let me know, then I can discuss. Otherwise, I don't know what to discuss, what not to discuss.
Getting it, sir.
Yeah, you are getting. Okay. I hope that most of you are getting. Okay, thank you for confirming. Okay, so what do you got? What up to what you have reached?
सर टेस्टिंग डेटा टेस्टिंग और ट्रेनिंग डेटा सेट कैसे एक बार बताएंगे कैसे करना है हमें 70-30 या 80-20?
Yes, that you can do this several ways. See, in this case, if you see the length of my TS,
that
it
is
is having
187.
187. So lot of data points are there. So one thing you can easily see that maybe if you want to take 80% into your, maybe 20% if you want to see that 20% is basically 37, roughly 37 data points. Right? So you can take this 37 data points maybe in your test set, the final 37 data points in your test set, and rest of them in the training set. So that way you can able to do. Now, if you see your my PS, it basically now it is easy to see. I mean, 37 means in one row you have 4, so you have to go back up to maybe how many? So you have to basically 37 divided by 4. So roughly 9 or 10 years you have to go back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe up to 2006, last quarter you can keep in your training set, and the rest of them you can keep in your test set. Okay.
Then you have written here na 2013, 4. So 4 columns हो गया, and 2013.
I have not done this. Yeah, I have just write something. I have to write. I have not checked all those things.
Okay.
I just write it. Yeah, I just write it. It's not like that. Yeah. So you basically what I have now said. If you want to do this, basically you have to write how much we told 16. So
2006.
So 2006. And 4. That way you have to do, and then you have to change this one to 07.
Yes, sir.
That will roughly break again.
Thank you, sir.
So training and testing data will not be distributed randomly?
No, because the reason is that in this case our aim is to forecast. So that's why randomly distribution does not make much sense.
So sir, if suppose in a training data model get trained on the basis of training data set, and we test it on the test data set, which is of a different period, and suppose the period for which we are going to forecast, there is a structural change in some factors. So the model will unable to predict the forecast the output appropriately, no?
Of course, because if you have sudden change and model is not trained with sudden change, how it will accommodate? That will always see. Just now you have very straightforward example. See, before COVID, nobody has think of that any financial index will fall that much. right?
Okay.
So, but it has. But how can you do that? These kind of things are all, I mean, completely sudden. No? So
Yeah.
structural changes are like that only. So if you beforehand you have idea that this is going to happen, then you may incorporate that into your model. But if you do not know how you can do that, there is no way.
Okay.
Sir, if possible, right, can you please again, right, explain, right, again, like in theory, sir, you explained that we will take the PQR, right, but second time here again, we are taking, right, PQR. But that was not actually discussed in the theory that we have to take 2 time or like that.
No. That's what I. Yeah, right. You are right. The thing is that I have in the morning session today, somebody asked me that question also. That what is that seasonal PQR? Okay, what is that seasonal PQR? And I what I should say, very broadly I answered this one, very vaguely I answered this one. The reason is that within this time bound, it is not possible to answer this question exactly. And exactly that's what's happening here. If you see the fit in this case, let me just go back. Yeah. So if you see that output of the auto ARIMA thing, this part, what is coming, so this part is the thing that what we have discussed in theory, that ARIMA PDQ, okay, ARIMA PDQ. Then we have another thing here, which I cannot explain now because it needs another session of explanation, that actually take care of the seasonal component. And if you see here, this part, this is also coming, that SAR, that means seasonal auto-regression, and this is seasonal moving average, this is also coming here. So this data, if you, this original data, this is basically the original data, this data has some seasonal thing inside. And that is basically taken care by this seasonal AR and seasonal MA part. And as I answered in the morning also, I told in the morning also that this actually did not discuss in the theory part. We have only discussed this part. And so the thing is that there are 2 things are coming because to take care of the seasonal part also. If there is no seasonality component in this data, then this part will not be there. And as I mentioned here, that even if you just, instead of auto ARIMA, if you just take ARIMA function, which I have discussed in the morning, so let me just go back. Yeah. So ARIMA, if you just remove this seasonal component from here, and you only keep this part with order 103, you will find that that estimates or forecast is not that bad. Of course, it will be little bad compared to this because this is the one of the best model for that. But even if you just remove this seasonal part, because the seasonality here is not very strong. So that's why if you even ignore the seasonality part and if you take that order is 103 here, leaving this seasonality part, you will find out that this thing will actually will work, but not as good as this model, not as good at taking care as this model, but it will not be bad actually. It will not be bad.
So what I did, I applied auto.arima to the training set. So the values of P and Q, they are changed now. It is showing 2,0,2.
Yeah, right. That's why, see, when I did this auto on the training set, I have not done in this way. What I did is that I fit a model based on the whole data, right? Now my question is that whether that model works well or not. So I have to, instead of doing auto ARIMA here, my point is that it is better to do the ARIMA here with
and
degree
1,0,3 जो भी उसका P and Q आया है first उसमें.
Right.
Thank you. Sir, how you are deciding H, the value of H?
Because here I have taken 39 because if you see the length of the training, length of the test data set, that's what I have taken.
Achha, 187 divided by.
No, that's test set. 20% part. What LNG length? Okay, so length this data part having 39 data points.
Okay.
Okay, so I just forecast all of them.
And sir, one more question. Sir. Can you
Yes.
explain once again the shock absorbing properties of this MA and AR?
Sure. Why not? I will try to do that. Okay. So what I was basically talking about is think from here. So shock is something, just now somebody asked the question, I don't know, that if you have a structural change or a sudden event, something happened like this COVID case, or sudden event like some natural calamities like earthquake or something happened, then you have a sudden shock to your data, and that may not be explained beforehand. Maybe after that shock has come, we can understand maybe because of that this shock has come. Okay? So if that kind of shock happens to a autoregressive model, then what happens is that suppose time series is going like that. At the point I have x1, then x2. As time series is going this way for some time, maybe x10, then suddenly we got a shock at the point 11. So this value will have either quite big compared to that or quite small compared to this. Okay, so either it has a upper shock or it has a lower shock, something. So then in case of the AR model, what happens is that the next value x12 should be alpha times x11 plus some error, right? So if this x11 is quite big, then most likely this x12 is also going to be quite big, because that depends on alpha, of course. But if suppose your alpha is close to 1, so then what will happen, because this one is having a big value, naturally this one also going to having a big value. Okay, so then when I go for x13, that will be alpha x12 plus epsilon 13. Now again x12 is a big value, so this one is also x13 also going to be a quite big. So that means that suppose I have something is happening here, then suddenly I have a shock. So this data actually, this time series actually shoot up. Then to come back to the normal, it will take a long time. Okay, it will take a long time to come back to the normal, not here. Okay, but if you go for AR model, what happens for AR model is that here the previous value does not have the effect directly, rather the effects are coming from the error, previous error and so on and so forth. So now if in this case what happens is that suppose again that I have x1 to x10, then sudden shock has come at x11, it is either suppose it is a upper shock, then x12, that is basically beta times epsilon 11 plus epsilon 12. Now of course, because here I have a shock, epsilon 11 maybe will be little big, epsilon 11 little big, so x12 will be little bigger. But now when I go for x13, it is basically epsilon 12 plus epsilon 13. So now there may not be any effect of this shock in x13. So things happens in this case, maybe time series is stable somewhere, I have a sudden shock. Then for MA model, this actually comes down very quickly. If it is a AR model, maybe it will happen like that. It will take long time to come back. But if case of AR model, that this will come back to stability quite quickly. So that's why that noise or sudden shock quickly vanishes for MA model, and for AR model, it has an inertia property that it takes long time to come back.
Thank you, sir.
Okay. Yes. Anything else from anybody? So what about hands-on? All of you have got that this kind of error, and again, I hope that you got that errors are at least the scaled error are not very big. So forecasting is not very bad actually. It's okay kind of forecasting. And we can do the forecasting in this case with ARIMA model. Of course, we can have better thing, but ARIMA is not also bad. And hope that you have also noticed this one. Every time the error measure for test set is always bigger than the training set. And intuitively that makes sense, because training set, when I am finding out any error measure, that is basically kind of the residual. So I use that point to fit the model, and then I try to estimate the error. So naturally error will be less on the training data set, and in case of the forecasting or the test data sets, the error should be high, and that is actually true. You can see everywhere that is. So everything is smooth with everyone. In the hands-on session, it's not that you have to only ask from this coding at this things. Some of you have already asked something else. You can ask those things also if you have any doubt, anything I can explain to one again.
Sir, can you tell me, sir, about this multivariate time series? Sir? Little bit idea.
Okay, multivariate time series basically, see, if you try to model a multivariate time series, things are, I mean, not.
So actually, what does it mean, sir? Actually, because in the time series, univariate, we have only just one variable, right? Then, and we have time. Then multivariate, what we have actually, how?
Okay. I think best answer can be given by showing this data actually directly. So if you see this data, US things, you see what you have. Not this one. So this is the US change data, right? So in this case, you see that in 1970 Q1, I have different things there, like consumption, income, production, savings, unemployment. So each of the column is a univariate time series. So when you think everything together, that is basically a multivariate time series. Okay, makes sense?
No, sir.
So now,
what will be the objective? Yeah, yes.
Yes. Now, if you try to work on multivariate time series, for example, suppose I want to predict some unemployment, because unemployment is a very important thing for a country. So I may be interested to predict or analyze the unemployment. So now this unemployment may depend on consumption rate, maybe depend on production rate, something else. So if you want to model the unemployment, if this consumption, income, production and savings are not there, then maybe I try to model unemployment like ARIMA model or something univariate model, I fit to that. But when I have more data on some other time series, then maybe the unemployment is affected by the consumption, or other way around I can see that consumption level actually affected by the unemployment, because if lot of unemployed persons are there, then naturally the consumption will be low for that society. On the other hand, that most of the people are employed, then the consumption level will be high. So if I try to model the consumption level like we have done, we have used the univariate one, and basically what we did, we tried to do, I mean, kind of from the previous value, I try to forecast the current value, or I try to forecast the future value based on the current value and the past value. Okay, or along with error. Error is also current error or past error. But suppose now I am available with in ununiform unemployment data. So Now the model can be even improved because I can incorporate the unemployment into the model so that I can forecast the consumption much better. So if I want to do that, roughly speaking, what I have to do? For example, suppose this is basically the third quarter of 2021. Now, suppose I want to forecast what will going to be the consumption for 2022 first quarter. So if I think that consumption is affected by unemployment, then first I have to forecast the unemployment for the corresponding quarter, the first quarter of 2022. And once I have that forecasted value can be incorporated to forecast the consumption level of the first quarter of the year 2022. So that's why when you have this multivariate time series, the model can change. The basic univariate model can be involved there, but along with that, the other available data may be used to increase the efficiency of the model. Okay? So, for that, there are a lot of multivariate models are there, filters are there. So people use them. And again, that giving detail is difficult now within in 2-3 minutes. I hope that basic idea is clear. Is it okay? What they try to do, why multivariate time series is important? Is it okay? Yes, can you hear me or not? So is the explanation make sense to you that who asked the question?
Excuse me, sir.
Yes,
Am I audible?
Yes. You can hear me, right? I don't know.
Yes, sir.
Okay, yeah, go ahead.
Sir, in case of multivariate analysis, let's say if we have 5 variables, so is it okay to take log of sum and do analysis while taking in the present form the other variables, like 2 variables I have log transformed and 2 and 3 not log transformed?
Not a problem. Not a problem as long as you see that generally have that. See this income here, for example. I mean, what we want that income for all the quarters are in the same unit. Then taking log is not a problem. But if they are in different units, first you convert everything into the same unit, then you do it. Yeah, it is okay. That it sometimes happens. See, it may happen that the consumption may be depend on log of income, not the income directly. That may happen. That is fine.
Okay, thank you, sir.
Okay, any more question?
Sir, can you please recommend some books from beginner to advanced level for this analysis?
Yes, that's right. If you look for forecasting, then you can see this book that I have given it here. You can look for this book. This is basically online one. You just go to the site. This book is available online. Okay, so it is a very nice book for forecasting, and lot of topics has been covered. So you can see this one. And leaving that for time series, there are many classic books like what is Blackwell, and I forgot that other name. So Blackwell's book is a very classic one, but the treatment there is not from the perspective of only from the perspective of forecasting, but other theoretical details also you can get that from that book. So those are some books that you can use, and this is a nice book for forecasting. You can find many things. Even in this book that some of you asked this question, what is a seasonal arima? All those things are actually addressed in this book. You can see. So I hope that you got these slides and codes, those things you got. So you have those references there. Okay, so I don't know. Do you have more questions? You can ask, or otherwise, I don't know. Should I conclude the meeting or should I wait for ending of the time?
So in linear regression, we say about the beta and beta estimate. So what is the difference?
What is the difference between beta and beta estimate?
Yes.
Okay. Okay. Let us answer. Let me answer you like this. Okay. So let me write somewhere. Maybe I'm writing here. So in the linear, think of a simple linear regression. Okay. So it is basically we write beta naught plus beta 1x plus some error. So now suppose your true value of beta naught and beta 1, suppose I am taking beta naught is maybe for simplicity, maybe take it 0, and beta 1 for simplicity, maybe take it 1. So my model is basically y plus y equals to x plus epsilon. And what is this epsilon? Epsilon is, standard assumption is that they are IID with normal 0 sigma square distribution. And for make it even simpler, let us take this sigma to be known and sigma is 1. Okay. Now, I can generate data from this procedure. There are standard way to generate data, and that is nothing but I can generate epsilon from normal 0, 1, and once I generate epsilon from normal 0, 1, if I know the x values, I can find out what are the y values. Okay. So suppose in this way, I know the x values x1, x2, so on, so forth, maybe xn, and then I generate epsilon 1, epsilon 2 up to epsilon n, and then adding them, I generate y1, y2 up to yn. Is that process is fine?
Yes, sir.
Okay. So finally, what I have bivariate data like xi, yi. Now I forget about this epsilon because this is a way I generated it, but once I generated it, I got this is my basically data where I runs from 1 to up to capital N. Okay. Now based on this data, I can do this least square estimate for beta naught and beta 1. Now when I do that, you can do it in R. Check that beta naught, the estimate of beta naught may not be exactly equals to 0. It will maybe close to 0, but may not be exactly equals to 0. Similarly, estimate of beta 1 may not be exactly equals to 1 and will not be exactly equals to 1 most of the cases. And it will be close to 1, but will not be exactly 1. And that's why basically the true value we generally denote like this. It is beta naught and beta 1. And when you do the least square estimate, you got a guess of the true value. That may not be exactly equals to the true value. This is the estimate. Estimate means guess of the true value. and those guesses or estimates we generally denoted by this hat. Hat is basically some estimate of that.
Sir,
Okay.
Sir, sorry to disturb, sir.
Yeah.
Yeah, with the ordinary least squares, we get the actual values, na? So actual values.
No. That's what. Never. Actual value we do not know. See, if I have the actual value, then things will be completely different. Actually, we do not never know the actual value. What we are trying to do is that we are trying to estimate the actual value. In all statistical analysis, the idea is to estimate the actual value. Like that time series also, that forecasting. When I am doing the forecasting, the actual value could be something different, but I am just trying to have a guess of what is going to happen in future. In all the statistical,
that is true. But for in case of the beta and beta 1, we have calculated already beta naught and beta 1 mathematically by solving the equation.
No, but say that suppose you have now another point in you have n points, then you have another point n plus 1 point. Do you think same beta naught and beta 1 you will get? Naturally, the estimate will going to change even if you do all the calculations. So the calculation, the least square calculation that you are doing to differentiate it equals to 0, that is basically a way to find out that gain. It is never the true value. That's what I am trying to tell you. See that in this case, take this example exactly. That's what I am giving this example. That when you get this, generate this epsilon that you can do in R using that R norm function. You can do this. So if you generate this one and you suppose take some vector for xi, and if you add them up, you get y, right? If you add them up, you get y. Now you just take this xi, yi as your data and try to estimate what is beta naught and beta 1. You will never get it is 0 and 1. I mean, if you do this experiment maybe million times, after that also you may not get that both of them are equal in one case. Okay, most of the time it will going to happen, and that is basically the thing. That original thing I am basically there is something in background. I do not know these values. In this case, I am telling you, you know these values, but actually in practice, we do not know these values. What I am going to do, I am going to just have some guess for that. Based on the data, some guess for that. Now data changes, guess also changes. So whatever the data I have, based on that, I try to estimate, I try to guess the parameter value. That's what I am doing. That's why we use two different notations. That this only beta naught stands for true value, only beta 1 stands for true value, but when we put that cap, they are estimates, they are guess.
Okay, sir. Or sir, this concept is related to the sample and population, right? Like we are calculating for the samples. For based on the samples, we are estimating for the population.
Right? Absolutely right. You are absolutely right.
In this way, we can.
Absolutely right. You can answer because this is basically a sample. You do not have the population because you have infinite point there in epsilon can take infinite point. It's a normally distributed. So you never have a population in this case. Absolutely right. You can answer from that point of view also.
Yes. And sir, these x and y's are the random variables and or not? X and y's.
See, y's are definitely random variable because epsilon is random. Okay. Now, what about x? X may be random, may not be random. But whether x is random or not, if x is not random, things you know how to do. Polash has taught you. Now, if x is random, then what people do is that they do the conditioning with respect to x. And when you do the conditioning with respect to x, that actually make x non-random. And if you do the analysis, regression analysis with respect to conditioning with respect to x, the analysis remains exactly same. So what analysis you have done for non-random x will hold for random x also. Most of the things, something may be different, but most of the thing will hold.
Sir, each xi is random variable, na sir? Each xi or each yi?
Each xi is a realization, rather each yi is a realization from a distribution, from a random variable. See, here what I am basically writing, I am writing all the epsilon i's are normal 0, 1. So epsilon is some random variable which follows normal 0, 1. So epsilon 1 is a realization of epsilon. Epsilon 2 is another realization of epsilon, and so on. So forth. Does this make sense?
Yes, yes. Thank you. So any idea about the gray forecasting model, sir? In gray forecasting model, actually we use the differential equations, right?
Okay.
Then how these differential equations can used for the forecasting? Matlab, what does it indicate?
No. That can happen. See, I cannot tell exactly what it do in gray forecasting, but my point is that differential equation can come in. The reason is as follows. Forget about time series. In any case, differential equation coming. The reason is that maybe the differential equation is a good approximation of the original process. Like if you think of that predator-prey models or some models in math biology, they are basically, all of them are basically explained through the differential equation. Okay, or forget about that. Think about the even more simpler thing that what is called is basically speed and displacement. All those things are related through differential equations only, right? So if those things can be explained using differential equation, then maybe in some time series you can so the idea is basically maybe like this. So in this case, in our case, we are taking
let us differential equation is dy by dt plus
exactly
dy by dt plus ky equal to some constant, sir. Yes.
Exactly. That's what I'm trying to put it here. So what does this mean? This means basically this is yt as well as this is yt. Okay. So our case, what we did, we basically write maybe yt equals to, in case of AR model, yt minus 1 plus some error. Okay. So it is a linear one. So I write it in this way, but in some cases it may happen that your rate of change in yt, that is related to yt directly. Okay, and in those cases this kind of formulation may be meaningful, because this is, you can put as a change, rate of change, right? The differentiation is basically that what is the change, what is the rate of change. So rate of change may be related to yt, or rate of change may be related to even something else can come, maybe k1 epsilon t, that also can come. Yeah. So this way, basically, this completely comes from the, as I mentioned in the first lecture, that you have to have some idea about the background from where the data is coming. And from where this data is coming, maybe there it is meaningful to make this kind of model that the rate of change is related to y directly. So that's why this kind of thing is coming there. Okay.
Yes, sir. I'm just sharing right just for better understanding. Actually, I could not really understand. Just I am just sharing some one paper right on this. This equation is written, right? Please, sir, just have, if possible, sir, please have a look and please.
Okay. Share it. Share it. Yeah, share it. I'll look into it, but I just put in here that I have also very basic knowledge of time series only, because I do not work in time series, so I have also very basic knowledge. I will try. If I can find it out anything, I will let you. Okay. So how do you share? You will send me by mail? Oh, you shared here. Okay. Okay. Okay, so who is asking these questions? Can you tell your name, please? Okay, I can see your name, Deepak. So Deepak, I think by seeing like this, I cannot make it out because it needs some time to understand. Okay, so I cannot just seeing like this, I cannot tell those things now. Yeah. So better you, if you want to discuss it, maybe you send it to me. Later we can discuss it. Or otherwise, we are going some other direction now. Okay. So you just send it by mail.
Yeah,
and,
sure, sir. Thank you. Yeah.
That will be better. Okay. Any more questions? Okay. If not, I think we can call off this meeting now. We can call off this discussion now. Is it okay? If anything there, you can ask, or I'll just call off the meeting. Okay, I hope there is no more questions, but you can share attendance link, please. See that attendance link I cannot share because I am not the main host. You have to talk to Professor Sairam for attendance and all those administrative things. Okay, so yeah, so please talk to him.